All right, come back. Back to the session, and in previous session we discussed about some sort of aspect of earthquake, and in that we covered one specific topic called faulting. So regarding the faulting, I hope there is a clarity. We have a three set of faults, and now we are continuing with the earthquake as a entire, the core of the core topic. I told you in the beginning that when we are approaching with the geography, so in geography have some sort of topics, small, many of them are coincide with each. Example, in the plate tectonic, learned that the volcanism, that the earthquake, that the young fold mountains, all of these are coincide. However, we haven't discussed about the young fold mountains as of now much detail. We have just took an overview, so later you will have a more clarity about it. Okay, so whatever the most immediate concepts are there, they are actually covering that with a particular topic. So in earthquake, we actually discussing about the earthquake, but yes, parallel to that, one small topic which is fault, we have also discussed about fault as well. Now moving back to our main topic, I would say that is the earthquake again. So based on the focus, or you can say hypocenter, the location of hypocenter in our earth crust, based on that particular, the depth from the surface. So based on the depth from the surface, the place at which the energy is released, or let's say the focus which is there in the crust part, or let's say the hypocenter which is there in the crust part, based on the depth, we can have a two set of earthquake. Here on the screen, you can see we have a shallow focus earthquake, and we can have deep focus earthquake. In this shallow focus earthquake, the earthquake which is going to take place from the surface up to the depth of 70 kilometers. Okay, up to the depth of 70 kilometers. Up to the depth of 70 kilometers. So from surface to the depth of 70 kilometers, if there is a releasing of energy, there is a fault, okay, if there is a strain, if there is a stress actually which is leading to the strength of rocks, led to the releasing of energy, and that will be called as what? Shallow focus earthquake. When the focus is shallow, when the focus up to the depth of 70, if it is beyond 70 kilometer, and specifically if it is somewhere between 300 to 700 kilometers, if it is between 300 to 700 kilometer below the surface, that will be termed as what? Deep focus earthquake. Now you will say that on the one side you told us that all the earthquake would take place in lithosphere, all the natural earthquake lithosphere, correct? So the depth which you shown in the interior part of our earth with respect to the lithosphere, that depth was 200 kilometer only. That was average. Okay, that was average. In some part of our earth, the lithosphere is somewhere 100 kilometer thick, whereas there are some parts in our earth crust where the lithosphere much thicker, 500 kilometer, up to 500 kilometer lithosphere is there. Okay, and yes, we have certain areas in our world where the lithosphere is hardly 10 to 12 kilometer, 50 kilometer. That will be the depth of that particular lithosphere. So the layers, the concentric layers are there in our earth surface. All of these layers are varying in terms of the thickness. None of them have a uniformity in terms of their thickness. Okay, at somewhere they are thick, okay, they are thin, I would say. At somewhere they are thin, and yes, at some other places on our earth they are what? They are actually thicker. The depth is so much wide. So based on that, yes, we also have some areas on our earth crust, specifically our lithosphere, where we are having a 700 kilometer depth. So if the earthquake is taking place, or let's say if the releasing of energy is taking at that depth, such kind of earthquake will be termed as what? Deep focus earthquake. These shallow focus earthquake are most common. Most of the earthquake which you see, almost 75% of earthquake, so those 75 of earthquake are actually they are the most common. They are the most common one. However, these are the rare, obviously, okay, because the major part of our is almost the average part, if you effectively, if or thickness varies. It is in this way. Suppose there is a class, and suppose in class there are some students whose height could be 3 feet, 4 feet, 5 feet, 6 feet, 7 feet, 7 feet. What you will do? Going to add this number, you will have an average. If you do the average, so the average will be somewhere, let's say 6 feet. So you will say this is the average height. But we have a shorter students or shorter candidates, and we have a tall. So it is above the average, it is below the average. So it is same with respect to the lithosphere. So 200 kilometers is the average. We can have a less than that, and we can have a more than that as well. Okay. So when we are talking about the shallow focus earthquake, they have a lower total energy compared to the deep focus. They have a lower energy, and yes, these deep focus earthquake will have high seismic energy. The energy means here seismic one. So here we'll have a very high seismic. Here, if you see, this shallow focus earthquake is very destructive. What? Very destructive. Because the energy is released near to the surface. Surface is here, and like the depth is what, 70 kilometers. So the seismic wave will take a less time to reach on the surface, as the seismic waves from the focus, they are just 70 kilometers away from the surface itself. So they will take what they have to travel only 70 kilometers. Once they travel, they will reach to the surface. So the energy which is there, so that energy will be always greater as compared to the earthquake which are taking place with deep focus. So deep focus earthquake are what? Less destructive. They are less destructive because the center, or let's say the hypocenter or the focus, is 700 kilometers away. So from that much distance, if there is a propagation of energy, now that propagation of energy is there, that propagation of energy, when it is traveling, when it is propagating to the different layers of our earth, most of the seismic energy will going to absorb, most of the seismic energy will going to, less in terms of their impact, which is about to heal on the crust part. So here it is less destructive. Okay, deep focus. Now shallow focus earthquake are strong, less distance to travel. They have high intensity as epicenter. They travel far but weaker, and like they will take a more time to reach. That's why they are weaker actually. Found at all plate boundaries. You will see shallow focus, especially in continental, divergence, both aspects, especially transform and divergent zone found. Mostly this deep focus earthquake will take place mostly at the convergent plate boundary movement, especially wherever you have a subduction. Now I hope you think that 70 kilometer. So at that particular depth, we have what? The subduction zone. Oceanic plate is beneath the continent. As a result, subduction zone will be formed, and because of the zone, what will happen? Earthquake take place. Okay. So mostly at the convergent plate boundary movement, we have got deep earthquake. Here you will see Japan Trench. Here you will see this almost Tonga subduction. Then here you will see San Andreas Fault, which is shallow focus earthquake. Example, Himalayan region, Nepal. So in 2000, very shallow focus quake earthquake actually is, that was an example of shallow focus earthquake. Moving ahead, seismic waves. So the energy which is actually propagating from this source, all direction, when it is in the crustal part, that will be body waves. It is there on the surface, that termed as what? Surface waves originating or their source. So first of all, when the energy is released here, when the all of the sudden the rocks stress greater beyond their capacity, beyond their strength, they will be releasing of energy. So here is the point from which the energy is releasing. When the energy is releasing while radiating in all the direction, there is a one point where the energy reach to the surface. So the point at is located on the surface, that will be termed as what? Epicenter. So now the epicenter is act as a source for the for the surface waves. So epicenter is the source for surface waves. So here we will have what? Propagation of surface waves. See here, if you see in this particular part, so this is what the crustal part, body waves, and these waves which are here, these waves will have both kind of set of movement, vertical as well as horizontal, whereas these will have a majority horizontal kind. In terms of direction, I would. So we have a two set of seismic waves. We have a body waves and we have a surface wave. Body waves in terms of P wave and S wave. P wave is basically called as primary wave. S wave is called as secondary wave. We have already covered this. Okay? And P wave can be termed as longitudinal wave and S wave can be termed as transverse wave. Surface wave, we have a two set of surface waves which are originating from the epicenter, and we have a two set of surface waves, among which we have a Rayleigh wave and we have what? Long wave, love wave, or L wave. I don't know why this name love wave is here. So it is causing lots of destruction of the hate waves. But anyways, accordingly, some textbook you will see the name is long wave, or you can consider this as L wave. So this will be R wave, this will be L wave, this will be S wave, this will be P wave. Okay. So these two body waves will be here in the crustal part, and these surface waves will be here on this. They will lead to the horizontal displacement of our surface. They might roll it, they might drop it, they might, destroy the horizontal surface. And when we are talking about the body waves will lead to the changing in the rock slabs which are there in our interior, okay, which are, let's say, from the surface. They are actually located from the surface up to a depth of, let's say, 10 kilometers, 5 kilometers. So there will be a adjustment. You might have observed one condition, that there are some areas where the water bearing rocks are there, means water is there, the groundwater is there, and because of the tectonic activity, because of the movement in the plates, we might have drop groundwater level. It's because those rock blocks which are there in our interior parts, they might have readjusted or adjusted or misaligned because of the, obviously because of the waves, body waves, they were S. Because of that, rock blocks might have moved, and because of that movement, the water which is there, that have been dispersed towards the other areas, and in some areas we could. So that example is in the western Rajasthan area, where was a tremendous aridity conditions were there. So it has been observed that nowadays there is a huge water at the groundwater reservoirs. It's because of earlier the water availability was there, but it was very rare. But now the water availability is very common, especially in those areas where it was actually okay. So nowadays it is very common. It's because of the tectonic shift, or let's say earthquake. Because of that, the blocks which are there in our crustal parts, blocks might have accordingly. So they are positive as well as facts. Negative in terms of the surface. If you are living on this part, if you have building, if you have home, then moving ahead.